Hey everyone, so today I'm going to be showing you guys the Fibonacci sequence in my Intro to Algorithms number 3 video. Now this problem comes from projecteuler.net, it's the second one. I did not show you guys the second one in the second Intro to Algorithms video because it's a bit harder than the other one I chose to show you second. So if any of you guys are wondering, that's why. It'll make it a lot easier to learn if you just go from easiest to hardest. Anyways, if you guys don't know what the Fibonacci sequence is, it's kind of a famous mathematical sequence, I guess. Basically, you take two terms and starting at 1 and 2, and you add them together to get the third term, then you do 2 and 3, and so forth, all the way for infinity. Anyways, pretty simple, and what we're going to be doing for this Project Euler problem is, well, what projecteuler.net says is by considering the terms in the Fibonacci sequence that do not exceed 4 million, determine the sum of all the even valued terms. So first I'll type out a couple of the different Fibonacci sequences. Well, part of it. We have 1, 2, 3, 5, and 8. The only even ones we have are 2 and 8. Next we would have 13, and after that we would have 21, then we would have 34, then we would have 55, and then so on to 89, and then so forth. If you guys have seen it yet, there's actually a pattern in here, and that's that you start out with an odd number, then you get an even, then you have two odds, then you have an even, two odds, even, two odds, and the next one will be an even. So you can use that, or you can brute force it, which is what I'll be showing you guys how to do, because once you recognize this pattern, it makes your code so much smaller and like really fast. So that's also a really good thing about algorithms, is that you need to realize how those patterns work. But this will also show you guys a little bit more about how to just take a problem that you can't find a pattern in and still be able to get through it without doing anything too that would take too much time. So I hope this will make sense and help you guys at all. Also, another thing to notice is that if you take a preceding number and the number after that, so like 34 and 55, or 55 and 89, or 13 and 21, you start getting really close to the number 1.618, which is phi, it's the golden ratio. And I think after like the first 100 or so, that's actually a fixed ratio between the two. This one will obviously be 2, this one's less than 2, this one, and this one. As you get closer, I think this one actually is 1.618. This might be 2, but I know for sure this one is. Well, pretty sure. Anyways, yeah. Enough of my rambling. You guys might want to look that one up too. It's kind of cool. Anyways, to get started, we're just going to start defining our function. We'll call it fib. We'll give it a limit, which will be 4 million in our case, and so forth. Now Python has an awesome little thing that you can do called variable swapping, or at least that's what I call it. And it's where you can define two variables at the same time and give them two different values, or one solid value that they would both share. And you can also, if you're redefining them, you can do the same thing. So that's pretty cool, and that's what we're going to be using. We'll have x and y, and those will be equal to 1 and 2, which it works pretty well for what we're going to do. Now what we can do is make new, or z. I'll just put z because it kind of goes with what we're doing, and I'll first set that to 0. Now what we're going to want to do is also make a sum n, which will basically take which will be our answer basically, and we'll also set that to 0. Now what we can do is just say while z is not equal, less than our limit, which will be 4 million, then we want to do, we want to check if z is a modulus, modulus 2 is equal to 0. If it is, it's an even number. Now also, because we're doing this, we're starting out at 0, then z at the end of this will be equal to 3. So we have to, at the very end, add 2 to our sum. We could start our sum off with 2 or whatever you decide to do. I'm just going to add 2 at the very end of this, or actually, just in case I forget, I'll just start our sum off with 2, because it'll give us an offset of 2, and our answer would be 2 less than what it should be. Anyways, if it's even, we just want to say sum n plus equals z. Now we just have to take our numbers and swap them around so that we have everything there. At this point, z will then be equal to x plus y. That, in this case, it'll make it 3. We can then go down, or we can actually stay up here and say comma x, comma y, and say now we want x to equal y and we want y to equal z. And or actually, yeah, that works. We'll have it equal z. And now what this does is it says z is equal to 3, y is equal to, well, just in case, because I haven't been programming a lot, there's been finals at school, so not really sure if z would be equal to 3 if we were to define y as z this late in this sequence. So just to be safe, I'll put x plus y for the value of y, just in case something funky happens. Now we have z increasing to our limit. We're checking if it's even. If it's even, we're adding it to the sum, and we're doing the actual Fibonacci sequence. So now all we have to do is return the sum n, print fib of 4 million. There we go, 4 million. We'll save this with Control S and press F5, and we get our answer, which is right there. That was really fast. If you guys want to time it, look into the time module. It's really easy. You can time how fast it took to do this, because the printing out of it actually does take time away too, and you can actually just find out how long it takes to make the answer without printing it. So that's a pretty cool feature. 1 second, the phone's ringing. Be right back. Alright guys, sorry about that. Don't know where I was at, but yeah, so you can time it with the time module, and that's pretty cool. If you look into the forums, a lot of the time people will say, oh, I was able to do it in 15 milliseconds or something like that. Now if they're using Python, they're going to be using the time module for figuring that out. So yeah, that's pretty much it. Just for fun, just to see if we get the same number, I'm going to put this to z because of my own curiosity. Yeah, okay, so don't put z, put x plus y for both z and y. So, yeah, you want to put, if we're reassigning z, comma x, comma y, we want to have that equal to x plus y, comma x plus y, or y plus x. That's for you to decide. So yeah, thank you guys for watching. I hope that helped you. One more thing I want to say, I'm not sure if it's been mainly my subscribers that have been going to my website, but recently I've been seeing a lot more views at my website, even though it's not finished yet. When it is finished, I'll make a whole announcement about that. A lot of the things that I put videos about on here will eventually go onto the website. A lot of the basics are already on there. But yeah, when people go to my website and they click on ads or something like that, because I have an AdSense account, it gives me money and stuff like that, and the more people who go to the website, the more revenue I'll end up getting from more people going there and clicking on ads, even though it's a small percentage. But yeah, thank you guys if you're the ones going to my website and doing that, because it gives me money, makes it a lot easier to do stuff like that, pay for hosting, and all that cool stuff. Anyways, thank you guys for watching. If you liked the video, please like it. Subscribe if you want to see future videos, and comment if you have any questions or whatever about the video, or feel free to PM me if you just want to do that, or if YouTube says that your comment's too long. Thank you guys for watching, and I'll be seeing you guys later.